That's the video of Unit 3. All right. This video, we're going to be talking about systems of equations. So we talked about linear equations back in Unit 1, but now we're going to be doing nonlinear systems of equations. So no longer can we use our matrix unless you have like a super fancy TI Inspire or something like that. I think it's like a CAS that you would have to have, but it's super crazy. My guess is you guys don't have them. So I'm going to show you what we're going to be doing. So you can do systems of equations with any functions. It can be a cubic, it can be an absolute value. Really any time that we have functions that intersect, there is a solution point. So with these, a good first step to take, Apex will ask you this as well, but to isolate the variable so that way we can substitute it into the other equation. So remember, systems of equations just represent where they are meeting. So like if you see something like this, we have two solutions there. If you see a graph like this where we have a parabola and a line below it, they don't ever intersect, so there would be no solutions there. So no solutions there. This one has two solutions. And this last one down here, it's really hard to tell, but all this is doing is it's hitting at that point right there. It's barely touching that parabola. So this would have one solution. One solution. They will ask you how many solutions you see. Just remember, solutions are where they are intersecting. All right, so now to actually solve each systems of equations. So remember, a solution is where my line is meeting my parabola. So it's an xy coordinate where my line is meeting my parabola, where the x value is the same and the y value is the same for both equations. So if we know the x value is the same and the y value is the same for both equations, then we know the x must equal the y in order to be able to solve the systems of equations. So in this case, if I know that x and y are the exact same for both equations, notice I have y equals all that junk and y equals all that junk. They're the exact same. So what I can do is, since I know these both equal y and y equals y, then I can substitute this 2x minus 5 in for that y right there, such that I come out with the equation 2x minus 5 equals negative 2x squared plus 4x minus 1. Now it's just a matter of solving that equation. We have it only in terms of x. So what I would do, I would move over things, and I would move it such that we have a positive 2x squared. Let me turn on the light real quick. Hopefully that helps the shadows. Whoa, super bright. Focus, focus, focus. There we go. So I'm going to add the 2x squared. So plus 2x squared to both sides. So that makes 0 on that side. So minus 4x, and plus 1. So that makes 0, plus 1. So now I have this 2x squared minus 2x minus 4 equals 0. Notice that's all divisible by 2. So I'm going to go ahead and divide my entire equation by 2. So divide everything by 2 such that I come up with x squared minus x minus 2 equals 0. So now I can factor this. This is factorable. Factor is a very fast way of solving these things. So I have x minus 2 times x plus 1 equals 0. So I'll get a solution when x equals 2. I will also have a solution when x equals negative 1. So now what that means, remember, these are solutions where they have the exact same point. So we are meeting here. So if I have a solution when x is 2, I also need the y value of that solution. So how can we find the y value? Well, you can substitute it into either one of your equations. Makes no difference which one. I would choose the bottom one because it's a little bit easier to find the y value when we put in an x value, but it's up to you. It really makes no difference. So in doing that, if I want to find the y value when x is 2, I can do 2 times 2 minus 5, so that would be 4 minus 5, which would give us a y value of negative 1. So there's one solution. All right, my other solution was when x was negative 1. So I have an x value of negative 1, and I need to figure out the y value. So again, I can substitute it into this equation right there at the top of the screen. So 2 times negative 1 minus 5 will give me negative 2 minus 5, which would give me negative 7. So I have those two solutions, 2 negative 1 and negative 1 negative 7. Thinking about this graphically, the line 2x minus 5 would cross at negative 5 and do something like that. So there is y equals 2x minus 5. This negative 2x squared plus 4x minus 1 would be a parabola going down something like that. So I have two solutions that I can see. I graphed it kind of bad, so I know this solution over here is 2, -1, so it should really be crossing like right there or something. All right, and then I would have -1, -7, which is pretty close on our graph. So that's essentially what's happening. That's what we are not seeing if we don't graph this, but we are stating 2 points, not 4, 2 points, where the graphs are intersecting. All right, looking at another one. This is essentially the same thing that we're going to be doing the whole time. So again, I see that I have y equals -x plus 4. So if I put this in for that y right there, I have -x plus 4 equals x squared plus 2. Then I'm going to keep this x squared positive to make myself a little bit easier, and hopefully I can factor. So I'll add the x, and I will subtract the 4 to get 0 equals x squared plus x minus 2. Remember, because that is adding the x and minus the 4, adding the x and minus the 4. So that goes to 0 on that side. So now I can factor this one as well. 0 equals x plus 2 and x minus 1. So very close to the last one. So I'll get solutions of -2 for x and x equals 1. So now I have the point -2 comma something and 1 comma something. Remember, to find the y values, just substitute them back into your original equation. This case, I think it's a little bit easier to do this x squared plus 2 because it's not too bad. You could also do this one, but you can't forget about that negative out front. Be very careful with that. But if I take x squared and I add 2 to it, so -2 squared is 4, plus 2 is 6. 1 squared is 1, plus 2 is 3, to give me my 2 solutions. All right, moving on. Same idea again. There's really nothing different. This isn't terrible stuff. So I have y equals all that, so I can put that in for y. So -x plus 3 equals 6x squared plus 5x plus 3. Now I'm going to subtract some things. So add x, minus 3, minus 3. So 0, 0. I'll be able to add those, and 3 minus 3 is 0. So this gives me 0 equals 6x squared plus 5x. 6x, I'm sorry. 6x. All right, so you're wondering, we don't have another term. How can we factor this? But remember, you can also take out the common factor. These are both, these both have a 6x involved with them, so I can factor out 6x. So I have 6x times x plus 1. If you're confused how I'm getting this, I get this question a lot, but remember, you can distribute these things and get back to where you started with. You're taking out 6x, or dividing both of these terms by 6x. You need to be able to multiply and get back to what we started with. So that's where that x plus 1 is coming in there. So now, with these factors set up, this solution will give me x equals 0. This solution will give me x equals -1. Then we have the points 0 comma something and -1 comma something. I don't know what yet, but plug them back into one of your functions. So in this case, it is easier to do the -x plus 3. So if I do -0 plus 3, -0 is just 0, so this will come out 3. Now if I do -1 plus 3, see, here's where you need to be careful, because -1 is actually +1 plus 3, so this will come out -1, 4 to get our 2 solution points. All right, I'm going to keep going. 3 more, we're almost done. Oh yeah. Oh yeah, buddy. So same thing again. Y equals all this junk, so I can substitute it in right there. So 3x minus 1 equals -x squared plus 5x minus 2. Hopefully this factors. So I'm going to move my x squared to the other side because I like to have positive factors, so plus x squared to both sides. So that means I'll do minus 5x plus 2. So minus 5x plus 2. That makes 0 on that solid altogether. So x squared minus 2x plus 1 equals 0. So now this is cool, because this will factor as x minus 1 times x minus 1 equals 0. The reason this is cool, because this is really just x minus 1 squared, so I really only have one solution when x equals 1. Cool. That's fine. Remember, we're going to have some times, not on that sheet, where we only have one solution. So they'll only have one x value where they meet. That's completely fine. So that's just all that's happening in this problem that we're doing right now. So if we know that x equals 1, we can take this 1 to find the y value of our solution point, plug in 1, 3 times 1 is 3, minus 1 is 2. So I have the solution of 1 comma 2. That's it. All right, these last two are a little bit tricky because notice it's all jumbled up, right? But that's fine, it's no big deal. Because what I would do, and this is where this first part comes in, a good first step is to isolate a variable so we can use the substitution in the other equation to help us solve. So let's isolate a variable. It really makes no difference which variable we isolate or get by itself, just as long as you choose one of them to get by itself. So looking at this first equation, I would probably get the y by itself. So if we subtract that 3x to the other side, this is also y equals negative 3x plus 5. Now that I know that, I can take this, since I know it equals y, and substitute it in wherever I see y in the other equation. So this becomes 4x plus negative 3x plus 5 with that substitution plus 3x squared equals 4x squared plus 5. And then it's just a matter, again, everything's in terms of x, so solve for x again. It's the same thing we've been doing all day. So I have 4x minus 3x is x plus 5 plus 3x squared equals 4x squared plus 5. Now I'm going to think about my x squareds. I like to have them positive so that it's easier to factor. So if I subtract 4x squared to the other side, that will create negative x squared. So let's do it the opposite way. Let's move over that 3x squared. So minus 3x squared minus 5 minus x. So that side will make 0 now, and I have 0 equals x squared. Minus 5 plus 5 makes 0, so I have x squared minus x. So again, we can take out a common factor. So 0 equals x times x minus 1. This first one here, of just x, will give me the solution when x equals 0. This one will give me x equals 1. So I have 0 comma something, right? And I have 1 comma something. So now to figure out the y values, just plug them into your original function. It doesn't matter if you plug them into this one, or this bottom equation here, but the bottom equation is way more work. So I would just do this one since it's already in terms of y. So if I have negative 3 times 0, that's 0, plus 5 would just be 5. If I put in 1, negative 3 times 1 is negative 3, plus 5 is 2. So I have these two as my solution points. All right, last one. So again, our stuff is all jumbled up. So it makes no difference which one you solve for. I would see this equation. This equation looks more simple than this top equation. And I would solve for y, because notice if we solve for x, we'd have to substitute it in right there and right there. So we'd have to substitute it in twice. However, if we solve for y, we're just substituting it right there. So if I subtract the x, subtract the 2, this is y equals negative x minus 2. Then I can take that, negative x minus 2, and substitute it right there, such that I have negative x minus 2 as my substitution plus 5x squared plus x equals 3. So now it's just a matter of combining like terms. So I have 5x squared minus x plus x will make 0. Now minus 2, and I'll have to subtract the 3 to the other side. So minus 5 equals 0. So now notice these are both multiplied by 5. So what I would do if I were you is I would divide the whole equation by 5 to get x squared minus 1 equals 0. That will factor. It's a difference of squares like we were learning about. So x plus 1 and x minus 1 equals 0. This first one here will give me a solution of when x equals negative 1. This one will give me a solution when x equals 1. So to figure out the y values, remember just take the x value and substitute it into one of your functions. I would substitute it into this one right here where we have it solved for x. So if I put in negative 1, negative and negative 1 is just positive 1, minus 2 is negative 1. If I put in 1, negative 1 minus 2 would be negative 3. And there is our solution. All right. Congratulations, you're almost done with Unit 3. Just got to take the test. Don't forget to turn in the practice assignment to me. And please let me know what questions you guys got. All right, I'll talk to y'all soon. Boop.